I bet you do.
Yeah, I got the wheelchair guy.
This is today. I made it today. I said today, I did tomorrow. And you know what?
Oh no.
I cut my other ones after. You know, I didn't my you know. No, last time I talked to you, were all in the house. So
Holy crap.
Monday, Thursday, Friday. Wow. Well, you know, it's a oh, like 6 hours a week. Is that like what we did last year? That's a couple of hours more. Same kids. No. You did? Yes, I'm doing social studies only. I'm thrilled. And Ellery, no, Ellery. You know what? Did you like it? It isn't it's crumbled chestnuts in there, but these are cherries. Yeah. And this has figs and mayonnaise. Did you like it? Yeah, it's good.
Okay guys, sorry for not talking loud. There's a house full of people here. Alright Scott, I see you want to see number 14, so we'll start that. Okay. So as you approach 6 from the left, 1, 2, 3, 4, 5, 6. So you're approaching from the left. So you're approaching this dot. So that's 1, 2, 3, 4, 5. So the answer would be -5. Okay, for those of you who are chatting in, you need to tell me what number you want to see. Okay. All right, I guess what we can do is I can start going through this big matching or big chart here. So let's start with number 1 as I approach 1 from the right. Okay, you can see I'm approaching 2. right? So again, even though there's a hole there, limits are about approaching. Okay, Ariana wants to see number 16. Okay, whoops. All right, 16. All right, so we notice we can't direct substitute in. All right, and you really can't do any kind of factoring to cancel. So the method to solve this one is going to be to rationalize the denominator, or in this case, rationalize the numerator. All right, so what you do is you multiply top and bottom by the conjugate. Okay, if this is a negative, you put a positive here. Okay, all over, and you got to multiply top and bottom by the same thing. Okay, let's FOIL. In the first part, you get 2x plus 5. The middle terms will cancel out, so I'm not even going to bother with the O and the I. And then you get a minus 1. Okay, so that goes to 2x plus 4. Now I have this still here. Okay. And then if you notice, the top will factor. So I pull out and I'm left with x plus 2. Alright, now the x plus 2's cancel. And now I'm left with 2 over square root of 2x plus 5 plus 1. Now, can you plug in the limit? Alright, so you get negative 4 plus 5, which gives me square root of 1 plus 1, alright, which is 2 over 2, which is 1. Okay, so that was number 16. I'll let it sink in for a minute. Okay, we're going to jump to number 14. Oh, 11. Okay, so now we're going to do number 11. Let's go there. All right, the purpose of this problem here is to understand the domain. Whenever you have a domain, you're worried about two things: division by 0 and square roots of negatives. So in this case, I worry about 4 minus x squared. That has to be greater than or equal to 0. Okay, so if you clean this up, all right, now whenever you take the square root and you have an inequality, you take for face value the square root of 4 is 2. But when you do, the the opposite, because square root of 4 is plus or minus 2, you have to change the direction of the inequality. So in this case, it would be negative 2 less than or equal to x. Okay? So traditionally, we like to write our variables on the left-hand side. So we could say it's x is less than or equal to 2, and x is greater than or equal to negative 2. For those of you who like inequality or interval notation, you basically got negative 2 bracket 2. And if you look at the graph, it's just a semicircle. Okay? All right, then Moretta. Hey, Moretta. We're going to do number 2. Okay, we're going to take whatever's inside the absolute value. We've got to rewrite it. And you got to find the magic number, remember? So my magic number in this case is x is 3. So then what we do is we take 3x minus 9 plus 2 for all x greater than or equal to 3. Cleaning this up, we get 3x minus 7. Okay, so this handles this for all x greater than or equal to 3. But now we have to handle the absolute value. So then what we do, we take the 3x minus 9, negate the entire thing, move the 2 outside, and now we clean this up. And this is going to be for all the x less than 3. Okay, so this becomes negative 3x plus 9 plus 2, which cleans up to negative 3x plus 11 for all x less than 3. Okay. So that was number 2 for Moretta. We did 16. All right. Then someone was wanting number 9 and 14. All right. Let me zip through all of these real quick. So as we approach 1 from the right, I'm going to 2. So that's going to this guy right here. All right. Now if I approach 1 from the left, here's 1 right here. I'm still also approaching 2. Right? Because here's 1. So as I go there, that's also 2. If I approach, now since these are equal, that helps you answer number 3. Okay, so the limit from the right and the left is 2, so therefore the limit as 1 is 2. F of 1, okay, is right here, the dot, so it's at negative 1. Okay, so it's open hole here. It's a closed dot there. All right, as I approach 2 from the right, number 5, here's 2. I've got to come down here, so I'm approaching 2 from the right. It's approaching negative 3. Okay, right here. Okay. This one is going to be 2 from the left. So if you look at 2 from the left, it's approaching 2. Okay, I'm just going to fill these in for you guys. And we can go back, and if you have any questions on them, you can do it. This one's do not exist. F of 2 is 8. 2 to the right is 2. 2 negative. No, it's a negative 2 from the left. It's a 4. This one does not exist. F of negative 2 is 4. Let's jump up here. 6 from the right is 0. It's negative 5. 6, that does not exist. Okay, someone's asking for number 20 here. F of 8. If you look at 8, 1, 2, 3, 4, 5, 6, 7, 8. All right, and you can tell that this is kind of like an asymptote. So there's no value there. So the answer of that is does not exist. Both of those are going up to infinity. Okay, explain number 14. Moretta, do you want number 14 for this one? This 14 or the 14 on the back? No, that is 14. Sorry. 12. This 14? Yes, okay. Alright, so if you can't really see it, it's approaching 6 from the left. So this is 6 right here. So if I'm on the left, I'm approaching here. Hey, bub. Sorry, that was my son. So if you notice, I'm approaching this dot right here. So if you look, that's negative 5. 1, 2, 3, 4, 5. So that's why that negative 5, I'm approaching that value. This is 6 right here. Okay. I'll keep going on all the ones here. F of 6. 1, 2, 3, 4, 5, 6. Close dot here, so it's also negative 5. 8 from the right. If you look, it's going off to infinity. If I go 8 from the left, it's going negative infinity. And because the limit from the right equals the limit from the left, we say that's infinity. They both go up to infinity here. See them right here? Alright, now let's keep going. Negative 5 from the right. That would be 1. Negative 5 from the left is 3. Because these don't equal, this one does not exist, okay? Negative 5, it's got to be left and right. Then f of negative 5 is 3. So if you need to fill those in, that should be all of 14 there. Guys, I think you'll be fine. This is a pretty easy one. Because class is shortened tomorrow, I did put an extra credit on the test just to help out in case you make a goof. Alright, so I'm hoping everyone gets A's tomorrow. Alright, before we wrap it up, does anybody want to see any of the others? Okay. I'll wait a couple minutes here in case somebody wants to work something out. All right, Grace. Number 12. All right, let's do number 12. Where's 12 at? Here we go. All right, number 12. Find K such that this function is continuous. So there's a couple ways to look at this. Well, let's go for it here. So for it to be continuous, we got to know what f at that point is. Okay, f of 4, and that's also got to equal the limit as x goes to 4. Okay, 4 is our magic number. Okay, all right, here we go. One way you can do it, you can kind of set it equal, but let's clean this up here. We know we can't do the limit as x goes to 4 because it would hurt this problem. So let's do a little scratch work. X squared minus 16. This factors. Okay, whoops, getting ahead of myself. This one's up here. And then we have x minus 4 on the bottom. This cancels. Now I'm just sitting with x plus 4. All right, let's find the limit. The limit I can just directly substitute in. When I put in 4, I get 8, right? And then I just set that equal. Set equal. Sorry, hold on. All right, and what I would do, I would set it equal to the other expression. Well, we kind of made this easy. This whole expression is k. So in this case, k is 8. Okay? So again, I do the limit of this guy, all right? Because it's x can't be 4, so I'm approach left and right. So that's why I do the limit as the x goes to 4, and that would be 8. Then I set it equal to the other expression, which just happens to be k, so that kind of helps solve k right off the bat. Okay? So that's number 12. All right, 13 too. Let's look at 13. So, in looking here, find the value of c. All right, and this is our little c right here. All right, and so let's find out what the -1's our magic point. All right, so let's find the limit as I approach -1. So my left of -1, I'm using this guy. Okay, so it's going to be -x. So that would be what? That would be 1. All right. Now let's approach -1 from the right. And if you notice, it's all the x's just past -1. I have to use this expression right here. So -x squared plus x plus c. And remember it. If it's going to be continuous, that the limit at that guy, as I approach -1, has to be 1. They have to be equal to each other. Okay? So this is approaching -1 from the right. This one's approaching -1 from the left. So I do kind of like a little quick fix here. So I put -1 in here. So -1 squared is 1. So I get -1 minus 1 plus c equals 1. -2 plus c equals 1. Add 2, c is 3. Okay? So again, the logic was this. If for it to be continuous, I had to make sure that the limit from the left equals the limit from the right. Well, when I did the limit from the left, I evaluate it because I have to use the first function part. I get 1. Well, then that tells me that I better get 1 as an answer when I approach right 1 from the other side. So I just do a little algebra and equate it out. Okay. Hey Kanto, yeah, I did number 16 already. So after this stream is over, go watch it and rewind it, and you can see how I solved that. Okay. How many questions are on the test? I think I did. Depends on how you look at it, because there's a lot of A, B, and C and that kind of stuff. I want to say about 14 or 15 questions. For those of you joining in now, I did put an extra credit on the test, just in case you have a brain fart and you mess a question up. I did put an extra credit. I'm not going to tell you what kind it is, but you did try it already. You did see one. And it's not on the review sheet, but it's something you know how to do. Okay? And like I said, turn this review sheet in tomorrow, and we can get some extra credit on it. All right, let's see. Reading here. 16. All right, 13 too. Could you do 13? All right, I just did 13. All right. Again, for those of you just joining in, here's the answers to that big chart. I'll let it pause there for a sec. Okay, whelp. I'm not familiar with the term whelp. NVM, I'm assuming is never mind, not 20. Alright. Any others? Alright, so I think we kind of did them all. Again, real quick, when you're doing infinite limits, the degrees are equal. So like 15. This is simply look at the leading coefficient. So this no-brainer. It's just 1/2. Canto, I'll leave this on the screen for a minute. There's number 16, but go look at the, rewatch the video and you can see what that is. Okay. Any others? Alright, let's see here. Again, you can always watch the video and pause it if you want to see something. Alright, we didn't do this one, but again, the leading coefficient actually is this one. Okay, and then you got this one up here. So when the degree of the denominator is greater, okay, it goes off to 0. Okay. This one was D. I think we did that in class. That you should be good. Moretta, number 9, real quick, please. Okay, hold on. Let's look at number 9. All right, number 9 is, remember when we did, see, these are all infinite limits. Okay, and what happens is when you approach infinity, those gave you the horizontal asymptote. And that's what we're looking for. And you have 3 case scenarios for horizontal asymptotes. You got 0, you've got some value, right? Like in this case, where was it? All right, I'm sorry, hold on. Where was it? All right, no. Hold on, sorry guys. So like in this case, if you look, this would be the horizontal asymptote. Okay, so when we do limits at infinity, whenever we get our answer, that's a horizontal asymptote. So without even really graphing this, that's 1 and -1. I'd have a horizontal asymptote there, and it would probably do something like, you know, something like that. Okay? So with that said, let's go back to here. Alright. So if I have a horizontal asymptote, y equals a, then more than likely this is going to be both the leading coefficients, the degree of the top will be the same. So it would be d. Okay? The horizontal asymptote, the limit would have to be a, and then a would be the horizontal asymptote. Okay? Does that make sense, Moretta? Okay, a couple more minutes here. If anybody wants to see any more done, type it in now or forever hold your peace. All right, guys. Good luck tomorrow. Like I said, it should be really easy. You know this stuff, and because of the shortened class, we'll make it. I made the test a little bit shorter. And if you didn't hear me before, I did put an extra credit on the test to help out in case you mess one up. Okay, guys, have a great night. Talk to you y'all tomorrow in class.